Hello and welcome back to my YouTube videos for the Grade 10 Applied Math course. This lesson is 2.5, Solve Word Problems Involving Linear Systems. So previously you learned some elimination and some substitution as well as some graphing. So in this lesson we're going to be looking at how to use that in word problems. So the learning goals are by the end of this lesson, you will be able to solve problems based on realistic situations described in words or equations by substitution or elimination. And the page in the Unit 2 booklet we are working out of is page 19. So 2.5, solve word problems involving linear systems. Many real-life word problems can be represented using a linear system. These problems can be solved in a few different ways. Whether you choose to use the method of graphing, elimination, or substitution, you will get the same answer. Choose the method you find easiest to work with. Remember that sometimes we can't use graph paper. It's not available to you or what have you. So for a few things to remember, the first thing you should do is create let statements for the variables you are using. So that's just where you're going to say let x represent you choose, and then let y represent and you would choose there too. But remember that x should always be the independent variable, especially when we're working with x and y. And y should be the dependent variable. Okay, then we create two equations that model the problem. These are going to come specifically from your word problem, so just take your time. And try to use the sentence and find keywords that are going to help you create equations. The third step is to solve for one of the variables, then solve for the second variable, and then because it is a word problem, don't forget a therefore statement. So for example 1, Neil's little brother has a total of 8 cars and trucks to play with. For his birthday, he wants to double the number of cars he has. If he does, he will have a total of 11 cars and trucks. How many cars does Neil's brother have now, and how many trucks? So we have to first create our let statements. And in this example, we are not working with something that is a dependent and independent variable, so it doesn't matter what x is and what y is, and really you could even use different letters. You could use C for cars and T for trucks. I'm just going to continue to use x and y. So I'm going to say let x represent the number, the number of cars he has. And I'm going to say let y represent the number of trucks he has. Okay, once I have my let statements, now I have to create two equations that model the problem. So from the first sentence, it tells us that Neil's little brother has a total. So the word total means that we're going to be adding things together. He has a total of 8 cars and trucks. So that means that we don't know how many of each. So cars and trucks added together, there are 8. So I'm going to call this equation 1. For the second sentence, it says for his birthday, he wants to double the number of cars he has. So to double the number of cars, that means 2x. So it's 2 times the number of cars. And if he does, he will have a total of 11 cars and trucks. So we know that there will be 11 in total. Now, if there's going to be a total, that means we're going to be adding. So double the cars plus the trucks will equal 11. So that's equation 2. Now, if we wanted to use elimination, this one's actually pretty simple to use elimination because our y's both just have technically a positive 1 in front. So to use elimination, we could create a line underneath and just use subtraction because they both have a plus sign. So we want to be able to eliminate them. So y take away y will give us 0. So x take away 2x gives me negative 1x. Y take away y, like I said, gives us 0. Cross these out. We have our equal sign. And 8 take away 11, that's negative 3. So I have negative x equals negative 3. I need to get rid of that negative, so I'm going to divide both sides by negative 1. So I'm left with x equals 3. So now we know the number of cars he has. To find the number of trucks, we can sub this back into one of the equations. So I'm going to say sub x equals 3 into equation 1. So we have 3 plus y equals 8. Now we can rearrange this so that we have y equals 8 minus 3 and y equals 5. Okay, so now we know the number of trucks he has because y represents trucks. So we can say, therefore, Neil's brother has 3 cars and 5 trucks. And again, if you wanted to double check that that makes sense, go back and read the question. It says that Neil's brother has a total of 8 cars and trucks to play with. Well, 3 plus 5 is equal to 8. It also tells us that for his birthday, he wants to double the number of cars he has. So if we doubled the number of cars, that would be like saying 6 plus 5. And that it told us that if he did that, he would end up with 11. 6 plus 5 is 11. Okay, so that's an easy check. For example 2, we are looking at Mary and an investment. So Mary invests $3,000 in 2 funds. The education savings plan pays interest at 7% per year, and the guaranteed investment certificate, which is a GIC, pays interest at 5% per year. At the end of the year, she has earned $190 in interest. How much did Mary invest at each rate? So right away, one thing you should notice is that 7% and 5% we can't just put into an equation. They have to be changed into decimals. 7% as a decimal is 0.07. 5% as a decimal is 0.05. So we know that she invests a total of $3,000 in these 2 funds. First thing I'm going to do is just create my let statement. So I'm going to say let x represent the amount invested at 7%. And I'm going to let y represent the amount of money invested at 5%. Okay, we know that she invested a total of $3,000 into the 2 funds. We just don't know how much in each. So we can say the amount that's invested at 7% plus the amount that's invested at 5% is going to be $3,000 in total. It does tell us that she makes $190 in interest. So to figure out our next equation, we're actually going to use those decimals and that $190 in interest. We know that the amount that she gets from the first investment, that's 7%, plus the amount she's going to receive back in interest, so 0.05 times whatever she puts in for y, is going to add up to $190 in interest. Because you get 7% back from one fund and 5% back from another to have a total of $190. Now with an equation, these two equations, it's not going to be as easy as the first one in order to do elimination. So in order to do elimination, you would either have to get rid of the 0.07 or the 0.05, or you'd be multiplying, and it's just going to get a little bit messier. So I'm actually going to erase this number 1. Whoops. And I'm going to change this equation slightly. I'm just going to rearrange it so that I have y is equal to 3,000 minus x. So all I did here is I took this x and I moved it over here so that I could get y by itself, so that I can now use substitution. So that's going to be my equation 1. I'm going to sub equation 1 into equation 2. So all that means is I'm going to rewrite equation 2 out so that it's right there for us. Wherever I see a y, I'm going to sub in 3,000 minus x, because that's what y is equal to. So I have 0.07x plus 0.05. Now instead of y, I'm writing 3,000 minus x equals 190. Now inside of that bracket, there's nothing I can do. So all I can do now is distribute this 0.05 into the bracket. So 0.07x still remains. Now 0.05 times 3,000. I'm going to just pull up a calculator here. So we have 3,000 times 0.05. Okay, we're at 150. So plus 150. Now 0.05 times negative x, that's negative 0.05x. Now we're done with the multiplication, so we've dropped the brackets and we have equals 190. We're getting closer. We now need to rearrange a little bit more. We need to move this 150 over, or you could show that you subtracted 150 from each side. So we have 0.07x minus 0.05x. I'm just going to rewrite it, 190 minus 150. We can solve each side. So you're going to get 0.02x, and then 190 minus 150, that's just 40. Now we can divide both sides by 0.02. Okay, and we can pull up that calculator again. Say 40 divided by 0.02. Okay, we've got 2,000. So x equals 2,000. Okay, so that's the amount that was invested into the 7% account. Now to find the amount that was invested into the other one, I'm sure you could do this in your head, but we are just going to show our work. So we're going to say sub x equals 2,000 into, I'm going to use equation 1 since y is already isolated. So that was y equals 3,000 minus x. And in this case, we're saying x is 2,000, so we can say y equals 3,000 minus 2,000. Y equals 1,000. Okay, so now we can create our therefore statement. We said X represented the amount invested at 7%, and we are saying that X is equal to 2,000. So we can say therefore $2,000 was invested at 7%. And we found that Y is equal to 1,000, and we said that Y represents the amount invested at 5%. So we can say and $1,000 was invested at 5%. Okay, we're almost done here. So for page 20, we now have to fill out this table. So this is going to help you get comfortable with creating equations. So there are a few different scenarios. So for number 1, a caterer charges a flat fee of $400 plus $15 per person. Sometimes I do find that it's actually easier to create the equation and then go backwards and fill in the let statements. A lot of people can tell that what their equation is going to be. So in this case, it's $15 per person, and we know that that means a rate, and that's going to be slope. So 15x plus 400. When it says the caterer charges, that's going to be our y. So we can say that x represents the number of people who attend, because we know that they're going to be charging 15 per x. So we can say let x represent the number of guests. And we can say let y represent the total cost. Okay, find the cost after 30 people. So 30 people, that's the number of people, so that means x is equal to 30. To solve, all you're doing is putting x equals 30 into your equation. So we can write y equals 15 times 30 plus 400 and solve. So I'm going to let you solve the problem, but I'll help you with the equations. So for number 2, an internet package charges a flat fee of $10 plus 40 cents per hour. So flat fee, that's our y-intercept. And then 40 cents per hour. Per means a rate, so that's our slope. So we can write y equals 0.40x plus 10. Okay, and we have to use our let statements, so let x represent. In this case, 40 cents gets charged per hour. So x is going to be that per hour, that hour. So we're going to say let x represent the number of hours on the internet. And y is going to be the cost of the package, because that's going to be the total of the rate plus the fee. So we'll just say the total charge. Okay, find the number of hours of internet usage if the cost is 200. They're giving us cost. Okay, so cost or charge, that means that y is equal to 200. So in our equation, instead of having y equals 0.40x plus 10, we can say 200 equals 0.40x plus 10. Okay, and you can solve for x there. For number 3, the temperature of hot water placed in the freezer is 80 degrees Celsius, and it is decreasing at a rate of 8 degrees Celsius per hour. So we know that we start off at 80, and the rate is decreasing, so be careful here. That means it's negative. 8 degrees per hour, and it's going to be equal to y. So in this case, x is the number of hours that have gone by, because every hour that goes by, the temperature decreases by 8 degrees. And y is going to be that total, because we're going to start at 80 and we're going to subtract 8 for every hour to figure out what our temperature is. So we can say let x represent time in hours, and we can say let y represent the temperature. And if you think about it, this makes sense, because x is the independent variable and y is the dependent variable. So the temperature depends on how many hours have gone by. The problem is find the temperature after 13 hours. So remember hours, that's going to be our x. So we can say x equals 13. And then you can sub that into your equation to find y. And I'm going to let you do that on your own. For number 4, a tree's diameter grows by 1 3/4 centimeters per year. So I'm just going to change this to 1.75. And the tree's diameter is currently 12 centimeters. So we know that that is our initial value. So initial value is 12. And it's growing by 1.75 per year. So again, that's a rate. And it's going to be equal to y. So using that equation, we can go back and say what our let statements are. We can say let x represent, it said 1.75 centimeters per year. So we can say let x represent the number of years. And we know that y in this equation is going to be the total. So 12 plus 1.75 per year, that's going to be the total diameter. So we can just say let y represent the tree's diameter. And it's in centimeters. Okay, it says find out how many years will it take to have a diameter of 20 3/4 centimeters. So I'm just going to change this to 20.75. And it's giving us the diameter. So remember, diameter is y. So it's telling us that y is equal to 20.075. It's asking us how many years. So we're looking for x. So I'm going to let you solve that one. Remember that you're putting in y is 20.75 into your equation. Okay, and for the last one, number 5, a spring is 14 centimeters long with no mass on it and grows by 3 centimeters per kilogram put on it. So it's 14 centimeters long initially. So plus 14. So with no mass on it, so that's at the beginning, and then it grows by 3 centimeters per kilogram put on. So 3 centimeters per kilogram is equal to y, which is the length of the spring. So we're going to say let x represent, it does tell you here per kilogram put on it. So we can say the weight placed on the spring. Okay, and then let y represent the length of the spring depends on the weight placed on it. So we can say that y is the length of the spring in centimeters. So the question asks you, find how much weight, so remember that weight was X, so we're finding this, we don't know what X is, was added if the spring is 35 centimeters long. Well, length is Y. So we know that this is Y equals 35. So in the equation, you're going to sub in 35 for Y, and you're going to solve for X. Now for part B on that page, I'm going to leave this to you to do as well, because there's going to be lots of different answers here. So for each equation, create a real-world context. Identify the independent variable X and the dependent variable Y for each. Basically, you're just going to use this equation, and you're going to provide let statements. So let X represent something. Let Y represent something. And then you're going to create a problem. So you could say something like, Charlie makes $15 per hour. So in this case, X would represent the number of hours worked. And Y would represent total pay. Okay, so you can work on number 2 and number 3 on your own. Just create a problem in words that would make sense, that would go with the equation. For number 2, be careful here. This 0.05 should look familiar to you. This problem would work really well if you used percentages. So 5% is written as 0.05.